Here we have another u-substitution example problem, and we want to evaluate the following integral using u-substitution. And the first step in evaluating this integral is we want to define our u and du terms. And when we're thinking about which term in our integral to select for our u term, we want to think about derivatives. So when I look at this example problem, which term, if I took the derivative of that term, would give me the other terms within this integral? So when I evaluate each of these terms, so if I evaluate x, if I take the derivative of x, I know I get 1. So that doesn't really help me for evaluating the other terms. And when I look at this square root term, 1 minus 4x squared, I'll get negative 8x, right? So I have negative 8, and I know that, okay, I see an x right there, negative 8x, I see an x right there, so that helps me. So this bottom term, 1 minus 4x squared, is probably going to be my u when evaluating this integral. So I'll go ahead and set that as my u and take the derivative to get negative 8x dx. And then I can get rid of this negative 8 by dividing it by du. So I'll get negative 1 over 8 du is going to be my x dx. And so now when I look at my integral, I can see I have an x, a dx, and so that makes sense. I probably selected the correct u and du terms. So the second step is I want to back substitute the u and du terms into my integral. So I can go ahead and rewrite my integral. That way it's a little bit more clear by putting the x out in front and just multiplying it by 1 divided by the square root term. And so I can go ahead and substitute my du for x dx and my u for the term within the square root. And so what I'm left with is the integral of 1 over square root of u multiplied by negative 1 over 8 du. And so after a little bit more simplification, I'll get the following integral where I factored out the negative 1 over 8 and I got rid of the square root or the square root fraction and just put that as u to the negative 1/2 power. So now when we look at this integral, it's very clear as to how we're going to integrate. And we can go ahead and do that where we're going to add 1 to the power, divide it by the new power. So that's our integration technique for the u term, and then we'll multiply it by our negative 1 over 8 term, which was just a constant. And so we're left with the following expression. And the last step is we can go ahead and just substitute our original u back into our solution. So this u will get replaced by what we defined u as earlier. And then after that, we'll have our solution to this example problem.